Hello all. In this session we are going to discuss about Numpy, a very important numeric computation package used for a lot of data analytics and different packages like Matplotlib, Pandas, Seaborn, Plotly. So those all packages are built on top of Numpy. So Numpy is a very powerful and very useful package in data analytics. So let's understand the basics about this particular package. Okay, so Numpy is a library used for computation, so scientific computation and the data analytics. So it is a numeric Python, and used the basic building block or the basics of Numpy is a n-dimension array where the contents are homogeneous. So unlike list is a heterogeneous collection of objects. So Numpy is a homogeneous collection. Right, we have to have the same type of object, and usually it is numbers. Right, numbers means integers or floats. So those are the data we store in Numpy and process. Okay, Numpy is a very powerful core scientific package used for computation and numeric calculations. Okay, there is a linear algebra, there are sub modules available inside Numpy package for matrix manipulations and linear algebra and some of the statistical functions. Okay, it provides the high performance multi-dimensional objects, array objects. Okay, I am saying high performance, so we will be understanding how it is used as a high performance data structures. So we will be exploring that in the upcoming session, upcoming slides and the practice session. So this provides the advanced functions, the mathematical and statistical functions, as we already spoke about. Let me show you a quick example how it looks like. So if you look at the data here, there is a one-dimensional array, 1D array 2, 4, 6, 8. Okay, that's a simple one-dimensional array one can write, and very similar to list. Okay, no difference. So we will see what makes Numpy array much better later on, but the one-dimensional array is no different than the list. Two-dimensional array is no different than the list again, which is arranged in 2 dimensions. So similarly 3 dimension and so on. Okay, so we have some basic functions how to create such Numpy arrays using a list data structures, or you can create directly the Numpy arrays, which we will be discussing about. Okay, so there are some basic operations we can perform. Let me take you through the Jupyter notebook to introduce you how to perform or work with the Numpy arrays. Okay, we have already worked on list. Let's say this is the list contents we have. Okay, so what do you think? What is the output of LST into 3? Just think about it. Okay, if it is a numeric data, obviously we expect that every element should be multiplied by 3, but that's not the case. Okay, list works differently, because list does not necessarily hold all the numeric data, and it is not a numeric calculation, but it may have so many different data structures. So the way it works, the nature of list is now it makes 3 times the list and extend your list by 3 times. Okay, so that's the obvious thing we think about, but that is not meant for the same. Whereas if it is a numeric data, we should think about making such calculations as multiplying each element by 3. Okay, not the extension or extending your list. Okay, so let's try and understand how we can do the same thing using Numpy. Okay, first, before that, we have to import a package called Numpy. Okay, and then we can start using. So Numpy you can directly use on Jupyter notebook or any Anaconda IDE, for example Jupyter notebook or Spider. But if you are using any other IDE or a plain Python installed on your system, you may have to install it. Okay, and how to install is pip install Numpy. Okay, so the pip package, so we will be discussing this when we discuss about the details, more details about the Numpy package, how to use that, but before we use, we have to import. Okay, and the package can be imported, as we discussed in the module section. So we can import and install using pip utility, right? So I think this we have discussed already in the module session. So today we can directly start using, let's say, numpy dot array. Okay, I will create an array using a list. Okay, let me assign this to some variable. Let's say a equal to, and now let me check a. The type of a is nd array, and that's right. Okay, because a is now a numpy array we are creating using numpy modules array function, and we are providing lst, that is list. This contains, so you may directly use this like this. Suppose a equal to numpy dot array, and you get a numpy array. Okay, if you check a type of a, it is nd array. Okay, so this is how we can create a simple array. We can also import numpy and create an alias, okay, as np. Okay, this, yeah, numpy as np. This is what the people generally preferably use, because this makes more sense. Every time, instead of typing n numpy, so I can simply type np dot array, and you are done. Okay, so sorry, right? So this is how I get a, and you can perform some basic operations. For example, now a into 3. So this does a multiplication. It multiplies each element of this a array, numpy array, by 3. Correct. There are some basic functions as well. Let's say np dot sum a. So it does addition of all the elements. Okay, np dot mean a. So oops, sorry, just a minute. Mean a, you get the mean here, right? So let me delete this. Yeah, we get the mean. Mean means it's the average. Okay, whatever is there, you can just find out the average. Okay, so these are some of the basic functions we can think about using. Now np dot a range, I have another function called a range. A range is very similar to a range function which we have used earlier. So a range will create a range array, range of the values in the range of 100, starting from 0 up to 100, but not including 100, and it creates a single dimension array. Okay, and obviously needless to say, a range can also work the way range works. Let's say I can start from values starting from 20 or with some step size. Okay, if you want to get all the numbers starting from 1 and up to 100 and including 100, so I have to run up to 101 with the step size of 2. So this gives me all the odd numbers between 100 to 1 to 100, and we can see that. Okay, that's a simple function, very useful. Let's say I will create another array a2 or a1, np dot a range of 100. Now let's look at this, how we can see that there is 100 elements, right? So this is the basic way. This is how one can use, one can create. Now let me help you understand some of the important operators we can use, right? Suppose if I add 1, okay, I want to add 1 to a1, okay, and check what happened. Okay, so the every element was updated. Okay, I can multiply this with 3. Every element got multiplied by 3, but remember your a1 is still same, because we are not assigning back, because this is just a calculations we are doing. Unless you write this, the values are not going to update in the original numpy array. Okay, so that's how we can do the basic calculations, and we see that every element is getting impacted, every element is getting multiplied by the multiplication operator using another number. Okay, so yeah, this is the basic thing, and now let me also help you understand. We can do indexing here, right? So numpy arrays you can index, or you can find out the values. See, 0th index we have 0, in the first index we have 3, in the second index we have 6. So that's what we have printing here. The 6 value is at the second index. We can access using a of 2, right, and so on. If you move on, so you can access these values using various indices, right? So that's how you can print, you can get the values from the numpy array. So there is also a slicing mechanism available, for example 3 to 8, and that is what we are getting, right? The slice of a list is a list, slice of a string is a string, so slice of a numpy array is a numpy array, right? So the values we get is from third index, that means the value 0 1 2 3, third index means the 9, and up to 8 but not including 8. Okay, so we have seen that this is how we can actually get the slicing syntax, right? So let me repeat, we have already used this kind of syntaxes, okay, for numpy array as well. So the second is negative indexing possible, okay, and we can see that how we get this negative indexing, right? Let me just do that quickly for you. So -2, sorry, not a, it is a1, okay, -2 is 294. Here look at this, right? You are getting the values from the last, from the end, and the second value from the end is 294. That negative indexing is also possible. Now the next thing we have seen is the slicing concept. Okay, you might have to want to slice some numbers, so we can do that using this kind of a syntax. Okay, there is something more. Okay, I will continue adding here, but before that let me show you. I will create one array, okay, a1 np dot a range with 100. Okay, and let's check what a1 is and what is the dimension. There is a ndim variable, okay, which can be used, ndim, and here you see that it is a single dimension array. Ndim gives you a number of dimensions. Okay, a1 shape. Okay, shape is a attribute which we get is what is the shape, right? If it is a one dimension array, it is 100 by nothing, right? Since it's a one dimension array. Okay, so yeah, this is the basic things about the basic array, how we create. Now I want to show you one more thing. There is some function called a reshape. Okay, and let me see how we get this reshape. Okay, so reshape function will shape your array into the format whatever you are looking for. You may want to get it a 2-dimension array or 3-dimension array. We can do using reshape function. Okay, for example, this is a 1-dimension array. Now you are reshaping that with 10 by 10 matrix. That means it is a 2-dimensional array. Okay, let me assign this to some other variable, that is a2. Okay, now let's try and see a2 dot ndim, n dimensions, right? Yes, I can see it is a 2-dimension, right? A2 dot shape, it is 10 by 10. Okay, so we got our original array, that is a1, which was 1-dimension array. Now we got another array from the same, which is a 2-dimension array. Okay, any guess what is the value of a of 0? Obviously it is not 0, but it is the entire row. Okay, let me verify that. Oh, not a, actually it should be a2, sorry, yeah, a2, right? It is not the 0, but it is entire first row, correct? So that means we can have this indexes like this. We can create the 2-dimension array, and we can apply the indexing like this as well. Okay, let me just add up here. So we see that we can do this kind of indexing, if you want to. Okay, and so on. Okay, so this is possible, and this is what we are just trying to see. Now remember, we have changed the dimensions, and now we want to slice, and let's see how we can slice this. Okay, a of 0 is working, and now a of 0 colon 3, and let's try and see what happens. Yes, so 0 to 3, 0th row and the first and second is included and the third row is not included, and that's how we can slice. Okay, so there is a provision. This is how we can slice. In fact, we can also slice and pull out some small section out of this particular data, right? So this kind of a slicing we have earlier also we have seen how to slice. Okay, so this is what the slicing we can do. Now I have one more way of slicing it. So this works on rows, and then I separate with comma, and then I apply, let's say 2 or 3 comma 3 colon 8. Okay, look at this, the original array. Let me repeat this. I will write here once again, and now I see that. So what kind of array I got? Okay, so I got array from this and this section here, right? This particular block. Okay, so yeah, so this is how one can get it. Okay, so just to show you how you can see this is just a moment, from 3 to 23 to 27. So the selected portion on the screen is what you can see, the only that portion we are able to pull out. Okay, so can you think about getting these values? Just think. Okay, pause the video and type your command to get the selected portion on the screen. Okay, so I hope you are doing it. Okay, now just check if you could do the same. Okay, so now let me write the command which we were talking about. Suppose you want to get from 23, I think. Okay, I forgot which was the selected part, but you can verify your answers. It's not a big deal. I start from 0 1 2, and 2 means here up to from 2 I start, and up to 6, that means up to 7th row, that means up to 8 I'll go. Okay, 2 to 8, and then I start from 3rd index and up to 8, that means up to 7 I will be picking out, right? And that is what we were saying probably, right? Or it is not up to 8, but it is up to 7. Okay, so this is what I was asking. So I hope you understand this. This is how we can do slicing, and remember, this kind of slicing is little different this time, and this is nothing but it applies on your rows and then comma your columns. Okay, so this is the another type of slicing or the operations we do with the iterable, especially the Numpy array. Okay, so this is the 5th thing. I have one more interesting thing for you. Before I move on to that, let me repeat. So I hope you understand this thing, and here you see that these are the different ways how we can access your Numpy array, right? From a simple the index, then the negative indexing, then the range, that is slicing, then the multiple indexes, that is in case of multi-dimensional array, then another range comma separated for rows and columns. This is for multi-dimensional array as well, right? And the last thing here is we can also have an filter expression. Okay, so this is interesting thing. Let me help you understand what I mean when I have, suppose A2 is there. So out of this let me have A1 for now. Okay, A1 is your single dimension, A2 is your 2-dimension data, right? So suppose you have A1, so there is a provision to provide a conditional check inside a square bracket here, right? So A1, sorry, A1. Okay, so here you can see that it will filter out all the elements values whose which is less than 50. Okay, interesting, right? So how it is possible is because the condition will be applied on each of the elements, and that is the only thing it is filtered. Because if you work with this small portion here, it will say true, true, true for all the values which matches this condition. right, and rest of the things are false. And if I put this into square bracket and put as a condition in the index operator, then only those values will be printed. Okay, so we can obviously do little more here with respect to such condition check. Let's say A1, I will check one condition like A1 is suppose I want to get all the values divisible by 5. Okay, so let me try it first. Yeah, this gives you no how come yeah, I should have checked it with 0. Okay, so this gives me all the values which is divisible by 0. Okay, that's another example. Okay, so the one more thing I want to give you a different variant is suppose you have two conditions and there is a provision to use this A1 less than 50, and yes, possible. So all the values which is divisible by 5 and less than 50 from this array A1 are printed here, are filtered out. Okay, you can obviously save it to some other variable and you can keep using that. Okay, such two conditions also you can apply, you can put into and filter out. Okay, so it is very flexible. You can in fact flexibly type different things here. Okay, whatever conditions you feel you can add it here. For example, here I can use a OR operator, so the values which is greater than which is divisible by 5 or greater than 90. Okay, so all the values up to 90 it has just considered which is divisible by 5, but beyond 90 it is just printing all the values. Okay, irrespective of whether it is divisible or not divisible, doesn't matter, right? You can come up with any kind of such filter expressions, and that helps you to understand or pull out whatever is required. Okay, so then one more thing, here we have A1 is having 100 values, and we have seen how to do that using a reshape. We can reshape those values by 10 by 10 matrix. Okay, reshape function can be used with various arrays. Let me tell you, A3 equal to np dot a range of, let's say, 300. Okay, now A3 dot reshape 10 by 10 by 3. Okay, and let me see what happens. Look at this, right? This has created a 3-dimensional array. Okay, it's a 3-dimensional array which is created based on the numbers here, dimensions specified here. Okay, let me give you one more variant of reshape here. So whenever we have done earlier for single dimension to 2-dimensional array, we have calculated 10 by 10 matrix here, right? So now if I do the same thing once again with 10 by, let's say, 20, so this gives error. The reason is we cannot create 10 by 20 matrix out of 100 elements, and obviously it is not possible because for such a matrix we need 200 elements. So we have to make sure this calculation is proper, and we have to handle it. So at least one number you have to calculate properly. The second number, let me add another cell here, and we can also do this calculation. If you have one number proper, the other number is automatically calculated. For example, you gave 10, then by 10 automatically it calculates, because -1 means that is we are leaving interpreter to do that task. Okay, or for that matter you can use the first argument like -1 or maybe 20, and -1 means here we are not specifying what dimension, the system will automatically calculate. So 20 by only one possible number is there, so machine will calculate that, and 20 by 5 will be created, because 20 by 5 is the only combination which can be used when your second argument is 20. Right, so that negative -1 indicates that this one the system needs to calculate. The second part I am giving, right? So if it is 10 by 10, the first, if you mention 10, the other 10 is calculated. If it is 30 by 30 by 10, then we need to have 300 elements, so definitely it will calculate 30 by the other part is automatically calculated. Okay, so same way here I am trying to explore and learn something more, and that is 3-dimension array, and obviously we need to have 300 elements, then this value becomes a valid thing to work with. So a3.reshape, this gives you the reshape of your original 1-dimension array, that is a3 by with the 3-dimension array, that is 10 by 10 by 3. Okay, and this is how it looks like. Okay, now let me save this first somewhere. Let's say A4, I will save it with A4. Okay, and now if you check A4.ndim, obviously it is a 3-dimension now. Then A4 dot shape gives you 10 by 10 by 3. So A4, if you want to slice, if you take a 0th, then that is also a 1-dimensional. That first part of the entire list will be printed. Since it's a 3-dimension array, you get the first portion from the 3-dimension array. Okay, that's a 2-dimension array. So on this you can apply once again 0, on this you apply once again another 0 to get it a 0th index, so 0th value. Okay, this is where I have summarized these things. This is important thing. Just look at this, do some practice, and it will build your confidence, because this is the basic step where we start with the data science journey. So once we are clear and comfortable with the usage of NumPy and pandas, it becomes easy for us to move forward with the complex examples and learn much with the data sets. Okay, so let me take you through a couple of other important functions which you might want to learn, or you might explore this later on. So np dot let me see what is my a1. A1 is 100 elements NumPy array, 1-dimension NumPy array. Now if I use np dot h stack, okay, there are some functions okay, we can use to stack. Okay, maybe I will create one more a2 as well, np dot a range, before I use this h stack. So I got a2 as well, right? A2. Okay, I got a1 and a2, and now let me use h stack. I will use a1 comma a2, and it expects one position argument. I think I can use a tuple here. So h stack is stacking your two arrays horizontally. Okay, and that's why it is a h stack. Okay, it stacks right one after the other. You have 100 elements, so 0 to 100, and then it adds another 100 elements from the array 2. Okay, that's how h stack can be used. And there is one more function called vertically stacking, that is vstack. We can use vstack and see that how these values are vertically stacked. Okay, that means it has created 2-dimensional arrays, right? This is a 1 and the other is added to the original array. Okay, we can store that, we can save it into some other variable if you want to use it further. Okay, so this is about the basic functions. Maybe I'll explain you one more function. There's something called a linspace. Okay, linspace will generate the numbers between some range with the linear spacing of some value, right? So for example, here it starts from 0 to 30. There are 10 elements it will create. Okay, so definitely the 10 elements, if I want to create from 0 to 30, so those elements will look like this: 0, 3.3, 6.66, 10, and so on and so forth. Right, so these are the 10 elements, right? If you check the length, okay, can't we change? Yeah, we should, right? Yeah, we can check it, the length here, right? So we can just create, let's say a5 equal to, and you get a5 dot ndim. It's a single dimension a5. You can simply print it. You can check the length of it, a5, and you see that there are 10 elements, and those are linearly spaced, equally spaced between 0 to 30. Okay, so linspace is such a function. So we have so many mathematical functions as well. For example, if I do np dir of np, you will see so many attributes and functionalities available, which you can use, like absolute or add, and then all close, all true. So there's so many so many functions one wants to use. They have so many such functions available. Okay, so you can explore those. There are a lot of functions. If you explore more, you more confidence you get, and more problems you would be able to solve, because if you know, if you, even if you use one time, so that helps you to apply somewhere in situation where you find you want to do something. Okay, so concatenate, compress, copy, so core, cos h, right? There are so many functions. There's a huge function and very powerful. There's a huge library and very powerful library. Okay, I'll keep it here. Then let me move on and see, there is something called zeros. Okay, so we can create a numpy array with all zero values. Remember, the zero dot means these are the floating point numbers. Okay, np dot d type is there. Yeah, d type means it will it will give the type of the object. Let me see if I can. Yeah, we can do that, right? Let me use this a equal to, and if I see a d type, it will show me the data type of the a, because what all things it holds. Is it a numeric or it's a floating, right? And since I said this dot indicates this is a floating point number. Okay, so since it's a floating point number, the d type will give you the data type of this particular array, what data type it holds. Okay, np dot once, there is another function that is once. It will create all the array the array with all ones. Okay, you can also take 100 and then reshape here itself. You don't have to do it on other separate cell. In the same cell you can just cascade all these different functions together and apply and get whatever shape you are looking for. Okay, you can just use this. Let's say a6 equal to, and you will see a6 printed here. Okay, so yeah, this is about some of the basic functions. Yeah, I know there are so many other functions. So if somebody wants to explore, so np, you can generate some random numbers also. Let's say randint. So you can generate random integer numbers. Let's say 10. No, I think only one number we can generate here. So maybe let me try random. Yeah, so this also creates the random numbers between there are 10 numbers we want to create, and this random number will generate the random numbers whatever you are looking for. Let's say 110. So how many numbers you are looking for? 100. In fact, I wanted to create actually. Yeah, there are 100 numbers we wanted to generate on for a particular numpy array. Okay, we can also reshape it to that. Okay, reshape 10 by 10. So you will see there's a 10 by 10 array, or maybe you just take 20 and 5 by 4. That's okay. Okay, just to check, see it in a single screen, I am making little smaller shape and small number of elements in the array. So this is a small array where we are creating some random numbers between 0 to 1, and those are total 20 numbers we are generating, and we are putting it into a two-dimensional array of size 5 by 4. Okay, you can also find some unique data. For example, let's say a equal to np dot array. Okay, here suppose you have to suppose you have this array a like this. Now a dot unique, is there a function? Let me see if I can recall correctly. No, np dot unique, I think. Okay, np dot unique a. and let's see, it gives you only the unique data in the sorted format. Okay, this is another useful function. Many times you may want to explore this, understand how you use some kind of a unique data, because numpy array can hold different or the same data, right? So you may want to get the unique data, and that's the possibility that this is the function you can use. There are so many functions, guys, right? So you have to explore them, you have to understand what it is doing, how we are actually doing working with these functions, and that helps you to get maximum out of the usage or different usage you can perhaps work with. Okay, another important point we have been talking about is the numpy array is much efficient, much faster, right? So let me demonstrate you quickly how fast it does some computation. Maybe I'll take one simple example to create a list of in range, let's say million numbers. I want to create 1 million numbers, a list of 1 million numbers, and let me create two such lists and do some addition. Okay, a simple one, or I'll take little bigger number, 10 million numbers. Okay, so I want to add 10 million numbers from the two lists. Each list contains 10 million numbers starting from 0 up to 1 less than 10 million. Okay, so let's try and understand how we do the addition. Any guess how to add these two numbers? Okay, just think about how to add two lists, sorry, not numbers, right? These are the two lists we want to add. Okay, think about how to add, because we have seen simple lst1 plus lst2 won't do the addition. Okay, I think we have seen that lst1 plus lst2 is not a good addition. In fact, it does insert and stretch or extend your original list. Let me just demonstrate you that quickly. lst2 equal to, and look at this, what happened. It is I'm expecting the addition happens element by element, 2 plus 5 3 plus 9. This is what something I was expecting, but this does not work the way we are looking at. Okay, so how to add then? That's the question. Okay, how to add is definitely this is not the way. So let's get the result of adding result by doing a list comprehension, because after addition I want to see another list as a list here, right? So 10 million numbers, if they are getting added with each other, I mean the value corresponding values from each of the list, so we get another list with the added values. So what all values we are looking for? X plus y for x and y in zip. I'm using a zip function. Maybe if I have discussed already, I don't know, I don't recall, but let me quickly help you understand how zip works. Okay, lst1, we have lst1 and lst2 here. Okay, here I will use lst1 comma lst2. So it will actually let me convert it, because this generates this gives a generator object, so which we have to use to iterate over. Okay, and what it does is it gives you the pairing, right? The first element of lst1 and the first element of lst2 is paired together. The second element of lst1 and second element of lst2 is paired together. Okay, so that is what the zip will do, right? Many times if you want to iterate over two lists, so it is not sometimes not possible to iterate, or it's not good idea to use two loops and iterate over. So instead we can just zip them together and iterate over. Okay, now let's understand what is there in the result. I want to just get first 10 elements, right, just to check whether the addition is happening or not. So it is doing now. Yeah, it is done. So look, 0 2 4, that means the added, right? Because lst1 is having 0 1 2 3 4, and lst2 is also 0 1 2 3 4 5 6 and so on, right? So those things are getting added, and I am getting this list, right? If I continue this to print for 10 billion values, so definitely it will have a huge number of elements, right? How to check that? Last 10 elements, if I want to print, oh yeah, these are the last 10 elements we can print. So it looks like the addition happened. Okay, I don't want to print it, I just wanted to verify. Okay, but what is the time it takes? Okay, let me show you. There is one module called time, and time has a function time. Okay, this gives the epoch time. So 0 to, okay, t0 I will just catch before we do this calculation. Now remember, we are adding two lists. Okay, the time is not considered to create a list, okay, because our interest is to manipulate, to work with the data structure, and now we wanted to add two lists, and we realize that there is an addition happening and it takes some time. So let me see how much time it takes. Addition of two lists takes, I'll use this, right? Time taken for addition of two lists, colon, let's see how much time it takes. Okay, time minus t0. Okay, I'll convert this into milliseconds just for clear understanding. Okay, and let's see if what it does. Yeah, it is doing the addition, and it takes, sorry, I should have made it one more zero, because it is not 82 milliseconds for sure, it is close to 1 second, right? So 852 milliseconds is what time it takes for calculating addition of two lists, having each list with 10 million numbers. Okay, now let's do the same thing using Numpy arrays, because it is a numeric addition, right? So instead of this list, I want to use np dot a range, and I want to use, I'll just copy to avoid any mistake, so I will just paste it as it is, right? And I will name this separate differently. Okay, so now let's see, I get E2 as well. I have E2, so we got A1 and A2 and how to make the addition is, here it is pretty straightforward and simple, right? We can simply do A1 and A2 and we are done. So let us see what addition it is doing. See, it is less than 1/3 time. In fact, if it is more values, let me add one more 0 for each of these elements and check what is happening. So here if I process with 100 million, I hope it is 100 million, yeah, it is 100 million numbers. So it is taking quite good amount of time, it seems. Let's see